Venus is really a hellish place.
The surface temperature is 450 degrees.
None of our electronics will work.
You try to put something on the surface of Venus and it's destroyed in a few minutes.
Venus has the densest atmosphere of all the solid bodies in the solar system. Venus' surface temperature is hotter even than Mercury's, and Mercury's closer to the Sun, is because of this atmosphere that really keeps the heat in.
The surface of Venus is a ferocious place. It is 90 times the atmospheric pressure of the Earth. That's like the pressure 1 kilometer under the ocean. But a temperature of 450 Celsius, that's like the temperature of your oven when you're running the self-clean cycle.
The surface of Venus is hot enough to melt lead. So it is about as miserable looking and miserable feeling a place as you could imagine experiencing if you could stand on the surface.
You would feel very sluggish. You would not move very quickly. And if a gust of wind came, it would be very powerful. It could knock you over. It would also be very dim because it only receives about 3% of the incident sunlight that it receives at the top of the atmosphere because the atmosphere is so thick. A bit reddish, we believe, from the Venera probes and the Vega probes that went to the surface and took pictures of it.
How do you make a power system for the surface of Venus? That turns out to be hard. Not only is it hot, but it's cloudy. There's not much solar energy.
Venus does have some solar power on the surface, although it's a fraction of what is available here on Earth is actually available on the surface of Venus due to the thick cloud layers, due to also the red shifting of the light, and that solar panels don't work as efficiently. The other big challenge with using solar on Venus is that Venus has a very long night, about 60 days. You would have to go 60 Earth days, that is, without power. Therefore, one of the places we're looking to get energy is from the wind. Venus has a very thick atmosphere. Collect that with a wind turbine, and then directly transfer that to the wheels to drive you at low speed, high torque.
Could we perhaps make a rover that has a sail, so the sail propels it across the surface? The Venus land sailor concept that we have is a mission design we made called the Zephyr that sails on the surface of Venus. Instead of running on a motor, we can make the sail out of a silica woven fiberglass-like sheet, and we think that we can make high-temperature materials that can operate on the surface. The worst problem we have here is that none of our electronics will work. The longest-lived probe for the surface of Venus has been just a little over 2 hours, and that's the time it takes for the heat to soak in and begin to destroy the electronics. So we don't use conventional silicon. We use a new semiconductor called silicon carbide that can operate at these temperatures.
Well, vacuum tube and vacuum tube-based electronic approaches actually work really well at high temperatures, unlike modern systems on a chip. The problem with that, though, is the high pressure makes it challenging to maintain that vacuum for an extended duration. And how you do a rover that's much simpler and more basic than what your current rovers are for Mars because of the limitations of those electronics. We sort of took a look back and thought, what would it look like if we were designing a rover, but designing it back in the 40s or 50s? What if you just throw all the electronics off this probe? Just make the whole thing mechanical. Make it all Strand-Beast, like Theo Janssen's Strand-Beasts, or all steampunk, or even go back to the Antikythera mechanism, which is a mechanical computer that the Greeks developed in about 200 BC or so. What would you end up getting? How do we do not just the rover drive system mechanically, but let's make all our measurements mechanical as well, like sort of an old clock spring style thermostat. So this is a clock that is fully made out of stainless steel. It's been baked out at 460 degrees Celsius and has been operated in an oven. If we build everything out of off-the-shelf 300 series stainless steel, the coefficients of thermal expansion would be close enough that even when you're going to extreme temperatures like Venus, the entire assembly would just expand and contract together and you wouldn't get jamming. And by using graphite alloy bushings at each of the bearing surfaces, we could actually get it to run at Venus conditions.
So far, the electronics that we can make on Venus are not as sophisticated as the electronics you can make on Earth. We can make very simple calculators, but we can't make whole computers. So right now, when we talk about systems that can land on Venus, we have the sensors on the surface. We have the radio on the surface, but most of the processing power, most of the computers, most of the things that run the mission would be high overhead. We could either put them perhaps in an airplane that's flying 50 kilometers above, or maybe in a satellite. And it controls the probe on the surface, almost like you'd be controlling a radio-controlled car. We could send a probe to Venus that would be an airplane, not just a balloon floating passively in the atmosphere of Venus, but we want to make a solar-powered airplane. And a solar-powered airplane, in principle, could fly forever, as long as we can fly faster than that wind, so we can stay in the sunlight.
If you could get an aircraft to Venus, it will fly, especially if it's semi-buoyant, so that when it gets to the night side, it can just glide and not sink down to the surface. And when the time comes, it may sink down to the surface and we might get a profile all the way down to the planet. Some folks at Northrop Grumman have designed a concept which is a semi-buoyant airplane. It's called the Venus Atmosphere Maneuverable Platform, or VAMP. And that could survive for a few months. It's solar powered, it's filled with a light gas, either hydrogen, helium. You can have solar panels on the top and the bottom, because when you're in the middle of the clouds, there's so much light scattering that it doesn't matter where you collect the solar energy from, because it's very diffuse.
A lot from the clouds of Venus is actually a great place to be. If you're at about 50 kilometers or so above the surface, your temperature and your pressure are very similar to what it is here on Earth. In fact, it's probably the most Earth-like place in the solar system. However, there is sulfuric acid rain that you have to deal with, but with the proper coatings, you can deal with that. Personally, I love the idea of a human crewed mission to a cloud city on Venus, and love the idea that you would just need to wear some type of suit that would provide you with oxygen to breathe, as well as also a protection from the chemical air, but you wouldn't necessarily need a pressure suit as well. That being said, humans tend to not like the idea of not being able to be on firm ground, and the idea that you have to stay floating above the clouds, above this furnace essentially, in some ways is a hard sell. The other key challenge that you would have with Venus is how to return to orbit and basically get back off the planet, as you don't have a large launch infrastructure that you could use. So you sort of have to look at another approach for getting back out of Venus orbit.